Hey everyone, we're gonna jump into it and do some data analytics. Oh my gosh. Let's get ready right here. Data analytics, 3, 4 to 3, stat to a 1, data analytics, number 7, getting started. Let's do this. Okay, so we got data analytics 7 getting started. Let me clear the screen a little bit here. I'm gonna clear out. That's good. Clear out the screen. Clearing out the screen. Good to go. So with this, you can see data analytics number 7. We are going to be doing intervals for proportions and the mean. One of the first things we always do before starting this assignment is always look at the rubric where we can see the points. You need to put your information at the top. You need to include all required files. That's a point right there for just doing the things you need to do. We need to take a random sample. Confidence interval for the proportion. We have the correct analysis and output provided. Confidence interval for the interval, right here, conditions is named. We name the conditions and thoroughly explain why or why not the condition passes. All 4 parts of an interval. I am blank % confident that the true blank is containing the interval blank to blank. Correctly analyze and output the information right here. Briley, good to see you there. This is for the data analytics 7, joining the conversation. So we need to make sure to have the correct output analysis. Does it show up on the homepage? We'll take a quick moment here. Analysis Toolpak check, confidence interval for the mean. Found the same margin of error both with the step-by-step calculation in the Toolpak, so you need to make sure to do that. Confidence interval for the mean. Good to see you, Peyton. Condition is named to explain why or why not we pass this condition. Interpret the interval. I am blank % confident that the true blank is containing the interval blank to blank, and give the AI reflection. So make sure you follow all these and have all these. You can always dispute your grade if you don't think the grader graded it fairly. I don't think enough people do that. More people need to dispute grades. I mean it. Tell us, be like, I don't think I got a point here. Should I not get a whole point? So if you notice right here, the instructions give you this file. I'm going to download this file and open it up, but we're going to use a different file because I do not want to do your work. So I can see data analytics 7 in chapter 14 copies, not just start, just not 3. Yes. Okay, good. Good. So everything, so Briley, to address this, everything here, I'm going to enable edit on this. Okay. Original data. Cool. Everything is appearing except chapter 13, right? Everything shows up on your Canvas calendar. Everything shows up to be done except chapter 13, right? You just email me and say, hey, Brian, look over this. I think you should change this. Like, or be nice about it. Don't be like, this needs to change. Just be like, I was looking over my grade. Yes. Awesome, Briley. That's so what it is, and I'll explain this real briefly right here, and then we'll do the next section of this video, is I wish I could show it, but in the My Pearson gradebook, I have to manually click each grade to change it. There's no import grades. There's only export. Trinity, good to see you. Vicki from Vol Snacks. Is Vicky's picture anywhere? We'll talk about Vicki next. I'll finish this part of it, and then we'll do my ADD mind next thing. But Vicki, we get to be on the So with us fixing up grades right there, I had to manually click each grade, and then I was able to click through all of them because not many people had done the later assignments, but there's almost probably maybe 300 inputs. Each input takes about 20 seconds to do. I was kind of looking at it, and I was like listening to videos in the background. So if each input takes 20 seconds, it would take close to 2 hours of click. There's more pausing, but you have to click, and then hopefully there's no errors. But about 2 hours of clicking, and then there might be errors, and then if people are doing it awful. Yeah, it was not fun. So basically 13 is the last one. I did the other ones because I had to do like 70 or 80 for the other ones. So I did all the other ones, and then I had to fix other things. I had to copy the assignments, but I think it should be fixed. Everything is fixed except chapter 13. 13's not showing up, and that's why I extended it. 13, unlucky. So that's why I extended it right there, Briley. And Vicki, where's Vicki's picture? Did you tell Vicki, Trinity, did you tell Vicki that she was mentioned in a video from 5 years ago? And Vicki, man, there's a lot of videos of Vicki, and then we're gonna go back to the assignment here. It's not due till Friday. So here we go to the main screen. Vicki, there's Vicki on the Instagram. Vicki modeling the latest looks for the VolShop. So shouts Vicki and the VolShop. You're welcome right there. I figured we'd do that. VolShop, we got to give a high review right here. I'll go review the VolShop later. But I love how Vicki VolShop brings up a lot of pictures because Vicki, oh man, there's there's Vicki being awesome. Yeah, so many good pictures of Vicki. Vicki being amazing. Everybody loves Vicki. Helping students out with the green books back here. Vicki is one of the things that makes UT amazing. So shout out to Vicki. We're jumping back into our regularly scheduled lecture. Say hey to Vicki at the VolShop. That's a requirement. I'm gonna timestamp this video. Say hi to Vicki at the VolShop. Okay, Vicki. Oh, thank you so much. Yeah, we all love Vicki. So Vicki, if you have a bunch of students saying hi now, well, you already do. You might have a little bit more. Okay, with that, let's talk about this assignment. We've already gone over the rubric, which is your number one way to know how to get things done. Once again, if you're ever wondering how you're getting points off, check out the rubric, and you can always complain and be like, I don't know if I should have got those points off. So when you're starting the assignment right here, open up your Word document. In your Word document, I don't know if I can do that. We got a lot of extra credit opportunities. That's good. I kind of like that idea, Trinity. You're going to have a rush. There's going to be a line at the VolShop. VolShop's going to get mad at me. They're going to be like, Brian, you can't hijack the VolShop. Looks different. We'll address that next year, Peyton. We'll do that. Remind me, Peyton. We'll do it right after this segment right here. We're going to do the data analytics, put it in this video. Let's talk about how to do data, or Stat 201, data analytics 7, doing the assignment. Okay, here we go. So once again, the first things you want to put into the assignment are going to be your information. Please do not forget this. It's some of the easiest points you can get. This is not your information, but you can do search. We'll be adding those in at the end of the semester. End of the semester, extra credit all gets added in. So with this right here, so it's a nice bump at the end. It's like a bonus. It is a bonus. So put in your information, your actual information. Just change this over to your name, your email address, your professor. You're welcome anytime. Your name, your email address, your professor, your section, your time. Make sure to enter the right stuff. From here, we're going to start the assignment and actually do the work. Now, once again, I'm not going to use this data. We do give you a random sample sheet right here, which kind of walks you through it. Man, we make this a lot easier. Let's go right here. What did we give them, Terry? We gave them sheets to fill out. Look at this. Does it calculate for you? N equals 4. P hat equals 0.50. Standard error equals 0.70. Don't put these in. Z-score equals 1.96. Does anyone know where 1.96 comes from? Margin of error equals 0.10. These are calculation fields right here. Count if. Yeah. Walk up demand high. Yes. Count if. We did so much work for you right here. Is it not doing it? Square root of these values. Man, we did so much of the work. Let's walk through this. 95% confident. People know. You're welcome, Kira, for the extension on the work. Yes. Okay, let's walk through this. Generate a random sample of 200 rows in Excel. So to get a random sample of 200 rows in Excel, we are going to need to take and use the equals rand function. So we go over here. You see the equals number, or the random number right here. I guess I'll do it on the actual data. It's the same thing. We do equals rand right there. And I didn't close the function. Didn't even make the function. And that generates a random number. When you close it off, random number. Now make sure to double click and you get it across everything. Now what I like to do is I like to click the row and copy with Controller Command C and then paste with Controller Command C. And then you should get the option, maybe we need to right-click paste, where's our options? Paste special. Now this should make it static numbers right here. If you paste just the numbers, under paste special, we want to just paste the numbers, the values. And now these are static, they won't change. Since they won't change, we can just go up here to them and sort them. I'll do this process one more time. We've done this a lot though, but we can do it again. Now we've sorted the data randomly, so it's randomly ordered now. You see the numbers have been randomized. Let's repeat the process. If you notice, without a random number put in, we just have the sorted data with the IDs in order. Now we go over here and we put in equals rand and close it off. And we probably need to click it because I didn't spell it properly. Make sure to do equals rand. Does it like it when I do equals rand lowercase? The answer is probably yes, it worked. Wow, it usually doesn't work in other scenarios.
Wow.
And then you double click this edge right here, which pastes down. That's alternative to clicking like this. You just double click right there. Now you can go to the paste. Is this a paste? No. You can go to Control C or Command C. Control C is my option since I'm on a PC. And then Control V. I didn't copy it. Oh my gosh, what's happening today? Hit Control C and then Control V. And there's that button I was looking for. Now you want to go to paste values right there. Make sure you paste the values, which makes them static numbers. Notice it's no longer a formula right here. When you paste with the values, it becomes, look at the top right or top left, a static number. Static numbers can now be sorted by clicking the top and going to the sort under data. You want to go to sort, and I don't like doing that. I like to just go sort down. Doesn't matter if you sort down or sort up. Sorting is sorting data. So now it's been randomized again. You can see the numbers are random. So that is how to take a random sample. Okay, let's look at the next part right here. Generate our random 200, create an interpret. We're starting off the assignment 2 to 3, fully, final step to writing your journey. You're once again working for Vols on Wheels, helping us do our bicycle data. So this is bicycle data right here that we're trying to understand. Are people renting them? What's the weather? Download the file right here, generate your random sample, place the random sample in with your column ID, high walkup demand, and high walkup count. So I'm going to do different variables right here. Once again, we need to put the warning on the screen. Where's my warning? Warning. There's the warning. Okay. How do you... Oh, good question, Peyton. Let's go do that. So what I would do if I was you, so I would go down here to 201. Now, the reason you're going to 201 right past it is because 201 gets 200 rows. Does that make sense? Because why does 201 get 200 rows? Why does 201, when you go to 201, we've frozen the first row? Because think if the first row is the header, then you don't do 200 rows, you do 201. Does that make sense? So now if I wanted to take something like holiday, bingo, the title and the first 200 rows. So you have to include 201. If I want to include holiday right here, I can go copy. I'm going to click the top of it and then copy it. And once I've hit copy, go over to random sheet. And I'm going to put it in here for high walkup demand. We might have colored all the way down to 200. We did. Or 201. That's what we actually have to do. And all I'm doing is pasting now. Does that make sense? Does that make sense what I've done right there? You will not do holiday. You will do the other variable that you're supposed to do. Who follows me on that? You will not do holiday. You will do the variable you're supposed to do. So don't do everything I do. Do the right steps. And then for the quantitative, I'm going to take is it average temp? I want to do something else than you have to do. You're doing walkup count. I'm doing average temp. Go to the row, click, or go to the column, hit Control C, go to the other sheet, hit Control V. Once again, I'm doing a different variable. ID, same sort of thing. Go back to ID and hit Control C or Command C, and then go back over here and paste in the data again. So now we've done it. Do not have things filled out already, because I was just having fun. Brian just wants to have fun. There we go. So now, let's look at the next step. You don't need to submit a screenshot of your sample, but it must be created to proceed with steps 2 and 3. Create a 98.5% confidence interval. And I'm not going to tell you the answer to this, but I'm going to show you how to get it. Don't put it in the chat either. We'll have some fun. What is the z-score for a 95% confidence interval? What is the z-score for a 95% confidence interval? 1.96, 1.96, not 1.99, or 1.95996. To be very exact, 1.95996. 1.96. Peyton was so quick that they were like, I got this. Peyton got 3 some points for that. Peyton was just like, I got this. I know the answer. 1.96. You got it. And apparently, MuBot is not awake. So we're going to wake up MuBot here, because MuBot is supposed to bring us over to the apps screen. And he will here in a moment where we can go look at this. Or I can pull it up myself, because Here it is, the Adam Spanbauer app. And we go to between, and there's the z-score, or classically 1.96, very close to 2, or 1.95996. All you have to do is start changing this to 98.5. Now make sure it's the middle 95, and make sure you're using the normal curve. So the middle 98.5, I'm not going to tell you what that z-score is. I'm going to make a 90% confidence interval, which is 1.645. Statistician, it's 1.6449 technically, but 1.645 is usually what statisticians carry this out to. So does everyone get, I'm making a 90% interval, you're making a 98.5. So do not do my 90% because that's my interval, not yours. So with this, find that z-score. We're going to be using it later. Use the orange shaded area in Excel to calculate and record the confidence level, sample size, critical z, sample proportion, standard error, sample proportion, p hat, and the margin of error. Once the margin of error is generated, calculate your confidence interval. Submit a screenshot of the entire orange calculation area and the final interval. Okay, so let's do this. Man, ask ChatGPT to do it. Let's ask Brian to do it. So with this, our confidence, once again, please notice I'm doing different work. Making the interval. 19, 4 to 3. Stat 201, data analytics 7, making the interval for the proportion. So when we make an interval for the true proportion, the goal here is to figure out what is the true proportion of days that are holidays for our bike sales. We know from a sample of 200 that there's a certain amount of days that are holiday days. And I think we've basically kind of done it here. Count if. And I don't know why it's giving a divide by 0. Is it because it went too low? It should give us the amount of yeses and should give us the amount of no's. You would think, what's going on? Divide by G4. Oh, G4 is the count. So G4, wait a minute. G4 is here. This. Divide by G4. We should be able to divide by 200. There we go. That's got it. It was almost there. Why was the code broken? Because all we're doing is this count if function is counting if it is yes for this vector of space and then divided by 200. So there it is. That's got it. That's how many yeses there are. Oh, this is the standard error calculated next to it. Let's calculate the standard error. They're kind of doing it right here, G5 and G4. And G5 is P hat. And that means G4 should be Q hat. So what's Q hat? Q hat is 1 minus P hat. So right here equals 1 minus this. Is already given the 98.5? That's not right yet. That's not right. Look at that interval doesn't go because there's no margin of error right now. So the formula right here, let's write it. We can draw it out. This formula for P hat is going to be P hat is X over N equals P hat. And then the standard error is equal to P hat times Q hat over N square root. And that's what you see right here, because in G5 is P hat and in G4 is Q hat. And actually it's finding, it thinks G4 is the sample size and it is written right there. So this is wrong. It's calculating Q hat for us. So that is actually, got to double check your work here, right? This is actually N. We're supposed to enter them right here. That's an interesting way of doing it. And then we need the Z-score. The Z-score, as we found via the applet, was 1.645. Mubot's got the app on the screen right there. So you need to enter in, probably, I'd do 3 decimals, 1.645. You can enter in the Z right there. Now let's not do that. I don't like how that looks. Really? There we go. 1.645 right there. And it actually calculates for you the margin of error, because when you do the margin of error is equal to Z times the standard error, and Z star gets a star for you get to pick it. So we already figured out the standard error, and then the Z, which is right here, is right there, and that calculates the margin of error. If you look, it's 1.6 times that, which not quite 2 times it, but there it is. So it's 3.4%. So the answer for this, and this looks Looks iffy to me. Let me see here. Oh, no, it's right. It's right. I thought that was 10. That's why I thought it was off. Because 45 plus 34 is this. 45 minus 34 is this. Does everyone get what I'm saying? I'm just making it 45 for a moment, like pretending that's 45 and that this is 34 because their decimal place is the same. So if you go plus or minus 34, you get these numbers here. You get 79 with the plus and 10 or 11 very close to. Are people following along how this interval is created? The interval is created from, it'll be p hat plus or minus z star times square root p hat q hat over n. And you see these components right here, so everything's being solved out for you. You should have the answer right there that should create the interval for you. And so that's got the interval. We need to screenshot this and show our work. A little nice little applet to use. But once again, I'm doing different work. You have to find your right z-score. You should know what this is telling you. And let's think about it. How do we start off our interpretation? Can anyone tell me the interpretation to start on this? How does the interpretation start? Let's say interpreting and checking conditions. Stat 201, data analytics 7, interpreting and checking conditions. What is it? Anybody? Peyton or Peyton? Got both Paytons here. Or Pate or Kira. I'll give it a moment. Throw you some points. What's the interpretation? It's going to be I am whatever percent confident we are. This is not 98 right now. This is a lie. This is 90% because I changed the way I was doing it. I am 90% confident the true proportion of days that are holidays for this bike service, whatever we're doing, is contained in, let's see, whatever we're doing, is contained in the interval 1.9%, 1.09% to 7.91%, or you could say contained in the interval 0.0108 to 0.0791. That's the interpretation. I am. And we'll have Mubot put it in the chat when we say confidence right here. I am blank percent confident that the true blank is contained in the interval. Well, what do you mean of the time? Go further, Peyton. Explain further, and I'll try to explain. So you would say, I am 90% confident that the true proportion of holidays is contained in the interval 0.0108 to 0.0791. And that's the proportion. You could say percent, 20%. Graders should be fine with that. But that has that. It gets our interval, it gets our interpretation. How about those conditions? First thing is this needs to be a random sample of people. Also, this needs to be less than 10% of the bike sales, like at the end of contained in the interval. Not blank to blank of the time. Not to blank, and great job, Hayden, on the random. It's not blank to blank of the time, though. It's saying something like, I'm 90% confident that the true price of the steak when we go and buy it tonight will be $30 to $40 at the restaurant. Not of the time, though, because I'm saying, I think you're going to the idea of what a 90% confidence interval means, that 90% confidence intervals contain the truth 90% of the time. That goes to the theoretical idea of what a 90% confidence interval does, that if you repeatedly make them, 90% confidence intervals contain the truth 90% of the time. But the interval is an estimate of what the truth might be in. And the interval would be expected to contain the truth 90% of the time. But I think you're thinking of the theory that 90% confidence intervals contain the truth 90% of the time. But the interpretation of the interval is, I am 90% confident that the true price of the steak at the restaurant is contained in the interval $30 to $40. Does that make sense? So over repeated trials of steak buying, I would see the truth contained in there. Like, I would expect the truth to be in the, or 90% of the intervals that are made to contain the true steak price. Yeah. And there it is right there. Mubot has it. The of the time would be kind of the theory of making intervals, that 90% of intervals that are made would be expected to contain the truth. Good stuff. Great questions. What is the third condition? The third condition for the interval? Random, 10%, and what? What's the third condition? This is where we pause, because a lot of people just go to the third condition, but maybe you're right to this time. A lot of people go to the third condition very quickly, and they make an error. So what is the actual third condition? I have a really good video on this. I might even drop the link in the chat. It's this video. It's never too soon to start reviewing for the later
one
tests.
proportion. We'll come back. We'll do that here in a
So
moment.
loud, Brian. But there's the conditions. We are doing a test of a categorical variable. And with doing a test of a categorical variable, that means it is success failure. So once again, you can see these conditions on the screen right here. I would check these out. Links in the chat right there, but it is success failure. You are correct, Peyton. Yep, because we're doing categorical, it is success failure. Nearly normal is for quantitative. Expected cell count is for chi-squared, and there are some other conditions. I think this actually doesn't pass. Does everyone see I put my sample size as 100? I am. I am 90% confident the true proportion of holidays is contained in the interval 2.08% to 0.069. That made the interval tighter because we are dividing by the square root of n, because the standard error is p hat q hat over n. Good to see you, Elizabeth. And so when you increase n, the interval gets tighter because you decrease the margin of error, because the standard error is part of the margin of error. So small error, but it should be 200 sample size. Double check my work too. I'm not perfect. So we've interpreted the interval, we've checked the conditions, but for the third condition. The third condition is we need at least 10 successes, at least 10 failures in the sample. Here's the thing though. Notice how this p hat is 0.045. So p hat is 0.045 times that by 200. We have 9 successes. I am not kidding that when you do n equals 200, p hat equals 0.045, q hat equals, this is 1 minus p hat, 0.955. Awesome, Peyton, great work. This will be recorded for later. We have np hat equals to 200 times 0.045, which is equal to 9, and nq hat is, you can just subtract from 200. We actually fail it. Mine fails. I'd have to report that this fails. We do not meet the third condition. And I should show my work. And what this means is we don't have good reason to believe that our data follows the normal. When you have at least 10 successes, at least 10 failures, your data follows the normal. But if you don't have at least 10 successes, at least 10 failures, your data doesn't follow the normal. The more successes, the more failures you have, towards 50%, the more your data follows the normal. So I actually fail it because I only have 9 expected successes. It's close to normal, but we really want those 10 successes, 10 failures. It could, but I don't think it happens because you're doing a different day, different thing. Yeah, if you have way more towards 50-50, it's way more normal. So you need to have at least 10 successes, at least 10 failures. Know your notation. Leo knows
notation, brother.
So know your notation. Make sure to have the right answers. For people who tried to copy paste the numbers into the ID and just made it the sign, you may have to change. Nice job, Kira, right there. That means the number is so big that it's not able to display it and you can't see it. Kira, good answers in the chat. And ask more if you have them. Kira with some great advice, getting 5,000 points. Very true. And don't worry, everything was all right today. I was doing a teaching in the future classrooms. And so it was a webinar thing. And I was like, oh no, I can't do in person. But I'm doing fine. Thank you for asking, though. I appreciate that. I was running around this morning. I had 3 meetings. Busy day. And I'll go home and go sleep. But I got the gradebook fixed mostly. I'm so happy about that. I was not happy about the gradebook. Interpret the interval. Explain the third condition. We did that. It's success failure. Explain where the condition is met. NP hat, NQ hat greater than or equal to 10. Interpret your confidence interval with the 4-part structure. Once again, let's put this in the chat here for people to see. This is the I am blank % confident that the true blank is contained in the interval blank to blank. Make sure you know how to do that for the test. This interval is for categorical. Understanding the distinction is critical because this is proportions. So the true proportion for this interval, because I did whether or not it was a holiday. 92% confidence interval for the population mean using the walk-up window. We're going to do this step by step in Excel without the analytics Toolpak. We'll come back and check it here in a moment. And there we go. We'll use it here in a moment. Use the blue shade area to calculate and record these things. Let's do it. Okay. Wait. Terry, what we got here? No. No, no. Uh-oh. Error in the assignment. I can show this screen how to do this. A confidence interval for the mean is the following formula. The confidence interval for the mean. Uh-oh. Some people have already turned it in, I hope. Confidence interval for the mean is y bar plus or minus t star s over square root of n. So these are the things we have to identify. Y bar, t star, s, and n. 4 things right there. The margin of error is everything after the plus or minus. That is the margin of error. And the standard error are the values right here. This is together makes the standard error. The T is used for how confident we are. So that's the confidence level, basically. The T equates to how confident we are, like the Z in the last interval, where we had P hat plus or minus Z star P hat Q hat over N. This one down below is for categorical data. So this is for categorical. This is for quantitative up here. And sure, I can't spell today. And this is the standard error of this interval. It's the standard error. And this one has a margin of error of this. And I guess we should also say that this over here is known as the estimate, which is our best guess of the truth. So our best guess of the true mean is the sample mean. So that's the estimate. So that is how these intervals break down. And of course, the Z is used for percent confidence. The confidence level is the Z. Good to see you in a data analytics 7 in task 2. What is the 4-part sentence structure? Braddock, good to see you. It's this right here. Mubot's going to drop it in the chat for you, and I'll be going through that again here in a moment. Mubot's got the I am blank percent confident that the true blank is contained in the interval blank to blank. If you notice, there's 4 blanks. First blank is how confident you are. Problem pretty much gives that. Second blank is what are we talking about? The last one was the true proportion of days that are holidays for my example. And the last part is the lower and the upper. So the lower and the upper of the interval right there. So Mubot's got it dropped in the chat for you. But once again, be careful. I'm doing slightly different work, but very similar. You wouldn't make a horrible grade if you did what I did, but you shouldn't copy me, and you got this. But you'll use the same interpretation. I've left blanks in there so you can fill it out, like how confident you are, what we're talking about, and the lower to the upper. I think, did I mark what I'm doing right here? I didn't yet. Okay, let's mark this. 35, 53, stat 1. Please ask more questions. Ask everyone you got. Analytics 7 and confidence interval. So we have to fix this up a little bit right here. So we got sample size is true. Critical Z values. So this needs to be critical T. And this needs to be sample mean. Sample proportion we won't need. And we do need standard. Technically, standard deviation should come before this. Standard. Oh my god. Okay. That should do it. Good to go. I think that's got it. Okay. Fixed up. Now let's go and get those values. So you'll notice right here we have a lot of the stuff we need, but let's write it. We're kind of having you do it right here. Confidence for mine, hiccup, was 90%. There we go. So we would put here confidence level equals, I'm just going to write, we'll do another 90%, and I'm doing it for this reason. Once again, I'm doing work a little different than yours. Follow your instructions. Now we have sample size equals 200, and then we need to find the sample mean. So y bar equals, this is why we have to kind of use formulas. That's why we can't have nice things. Because we're going to go here to average. And on average, we're just going to open it up. And then we're going to grab this and go, whee! I guess I could have done the click trick, but it was so easy to do that. And then we're going to close it off, and there it is. So once again, make sure to put the vector, or you could just type the vector, and there's the average right there. So we have that. You know what? Since we're doing this structure, okie dokie. They say in Fallout. Okie dokie. So now we need the standard deviation. So standard deviation. Standard dev. Really? I wanted to go there and fix this. There we go. And the standard deviation is going to be very similar, except we go, I think it's standard. Nope. What is it? Standard deviation. Oh, what am I doing? There we go. Standard deviation is, I always forget, there's too many formulas. It's only compatible. Let's try it out. Let's see what happens. So let's just try this formula right here and go C2 through C201. And the answer is, it works. Whoa, it works. So that's the standard deviation right there, which is S. We just found S. We found Y bar. Next, we need to find, we know what N is, so we have to find T. To find T, we need to go over to the T applet. So there are ways inside of Excel to do it too. I'm trying to think if I remember the way. There's a function, but I prefer you to visualize it. I actually like visualizing this. We're doing a one sample T, so it has N-1 degrees of freedom. This is the T created by William Gossett, who worked at Guinness Beer. Know that for the test. One of those teach me the test moments. So since we have a sample size of 200, the degrees of freedom are 199. And you'll notice the 90% interval, which is not what you're doing, is very close to the other interval. The T is always a little further out. At lower degrees of freedom, the differences are more pronounced. But at higher degrees of freedom, the T converges towards the normal. As in, if I carry this to more decimals, you'll see that 1.6449 appear as we get to very high degrees of freedom. So the T is really meant for smaller sample sizes where the differences are not as obvious. Or, yeah, the differences are more obvious, I should say. So here it is, 1.6525. So that's going to be our T-score right here, which is going to equal to 1.6525. Double check your numbers. Make sure you got it right. 1.6525 is the T right there. And if you notice, we have all the components. We have Y bar, plus or minus T, S over square root of N. So let's find the standard error right here. Standard error is going to be the formula S over square root of N. So we simply go here and go equals to S over SQRT. Really? In R, you can just hit enter and it does it. Over square root of N. There we go. S over square root of N. So that's the standard error. If we times it by the T, we get the margin of error. So now we have to go here to, remember this is the standard error. This is what's in blue right here. You've got to keep track of your components. So now we go T, which is this, equals, because that calls the formulas, this times this. There we go. We'd say lower, upper. So now we're just going to take the mean plus or minus. So the lower equals to the mean, which is Y bar. And it'd be minus to get to the lower, the margin of error. And then the upper is very similar. We just go equals the mean plus the margin of error. There we go. There's our interval. I am 90% confident that the true average temperature is contained in the interval 67.26 to 70.41. I'll do it. You're still, oh no! Peyton, thank you so much. Echo in the chat. I forgot. I didn't eat my lunch. It's been such a busy day today. I got popcorn over there. It's been such a busy day. My wife made me a sandwich and I haven't eaten it yet. We'll end a tiny bit early and then I'll walk around and eat lunch. I drink coffee though. No energy drinks, just coffee. So there's how to create the confidence interval. Make sure to use the formulas. Do know these formulas. Like, understand what the components are that we create an estimate of the truth. What's your best guess of the true mean? The sample mean. Like, imagine you want to know if your friends are strong and you have two friends and they do pull-ups. One does 8, one does 12. What's your best guess of how many pull-ups your friends can do? One of your friends does 8 pull-ups. One does 12. What's your best guess of how many pull-ups your friends can do? Be like, well, on average, I guess my friends can do about this many pull-ups. 10. Mm-hmm. And that's what the guess is. The guess is the average. And then you would say, well, 10 plus or minus, and then we'd make a margin of error. We're not going to go plus or minus 2. That's not how the interval technically works. But the interval is trying to estimate the truth for, like, your friends. Like, on average, I bet my friends can do 10 plus or minus this. Does that make sense? So all you're doing is taking the average as the best guess and then creating a margin of error around it, like a plus or minus, to kind of hedge your bets. So think about how we make these intervals and what the point of the interval is, because we're trying to figure out what the true average temperature is, at least for my interval. And I think we're almost done with it, because let's look at what we have to do now. So that's making the interval right there. Wait, here we go. And then we need to interpret it. So here's the interpretation in your own words and checking the error, checking the condition. Okay, let's go to interpret and check conditions. Stat tool 1, data analytics 7, interpreting and checking conditions for the mean. Okay. So when we interpret the interval, we always want to use the I am blank percent confident that the true blank is contained in the interval blank to blank. So you look at your output right here and you think, I am trying to interpret the true average temperature. Now, since it's quantitative, that's the true mean. If it's categorical, it's the true proportion. So you have to understand the difference between these intervals. Categorical, I am blank percent confident that the true proportion is contained in the interval blank to blank. And then here, average temperature, or because that's quantitative, I am blank percent confident the true mean is contained in the interval. So just look at the data type, and that clues you in on what to say. Now we go down to the interval. It seriously had this stuff below here. So fill this out, make it look pretty. Fill out your interval. Tell me if the graders are mean. Sometimes when we do the work for you. It's all right there. It's being calculated. Let's just double check. M is 200. Confidence level 90. T. Oh, Terry's doing it for it right here. Look at that. It even does it for you. I made you do extra work. Standard error. Now you got to get the standard deviation. So we don't have the standard deviation yet. So what we could do is we can literally just grab, because see that is this divided by the square root of n. So we can literally just take and grab our standard deviation right there. There we go. Same standard error. Margin of error, same margin of error. Confidence interval not being calculated because we don't have the mean. Each 21. So each 21 is here. And why is the mean all the way over there? So equals to that. There we go. Ooh, that's not right. That's not right. Minus, this is where the margin of error is at. I think he wants you to move these. I think that's the goal, is you're like, wait a minute. Let me just move this right here. And then you say, wait a minute. Let me just move this right here. Oh, he says this is the margin of error. Well, you can move it. You can do whatever. As long as the answers are right. So there's the lower, there's the upper right there. Same answers. Once again, know how to do it. So I am 90% confident that the true average temperature is contained in the interval 67.26 to 70.42. And you can round these if you want. Grab the numbers right here. Round the numbers home. Delete, 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 delete. Round to 2 decimals. Good stuff. The conditions for this are random. We have to randomly collect these days. Less than 10%. We'd take less than 10% of all days there are for bikes and stuff like that. We should pass that because I believe there should be near infinite days. I'm going to get a little bit iffy if the graders are like, oh, we took more than 10% of the sample or of the population, but there's more than 2,000 days of bike rentals probably. I think we're good at the 10%. I need to talk to Terry on that one. And last but not least, the nearly normal condition. But here's the thing. We can check this via large enough n. This data right here, and you could use this if you wanted. We could go here to insert, and I think this is where we get the histogram. Oh, why is it not making my histogram? Let's go right here. You know what? Let's grab not that top channel right there. Let's go to insert histogram. Look at that. A little bit of bimodality. You could supply this right here for your argument. Since the data is not heavily skewed, a little bit of bimodality, a sample size of 200 will lead to a nearly normal distribution of the means. And this is the central limit theorem in play. So if you think right here, we have a distribution that looks something like this. And then if we have a very large sample size, the resulting distribution will be nearly normal. And this is the large enough n, but now it's part of the nearly normal. But if this is a good view of what the parent population might look like, because we don't have the parent population, our sample looks like this, but one could assume that the distribution of the means of something that comes from something of this shape would be nearly normal. So I think we're good. We pass it because we have an extremely large sample size. The condition is called nearly normal, though. Make sure you know that. The condition is called nearly normal now, and we were just showing that a moment ago when we were doing the test review in the video. It's right over here. You can see for the quantitative one sample t, the condition is called nearly normal. So there's the one sample mean, random 10% nearly normal for quantitative data. So that's got that part. I think now we need to do the Toolpak. So let's do that in the video. The Toolpak. So 40, looks like it's going to rain outside. Stat tool 1, data analytics 7, Toolpak. Okay. So interpret in your own words. Mention the third condition. We did that right here. I guess we skipped the Toolpak. Interpreting, wait. Where's the Toolpak? Use the Excel analysis Toolpak. Input the range here. Output the range there. Check both the summary statistics and confidence level for the mean. Enter the correct confidence level and the sample size n. Compare the margin of error summary statistics provided to you, the ones you calculated. Okay. Ensure they match. Okay, let's do this. I'm going to take a screenshot of this so I can keep it on my screen. Here we go. Let's go back here and open up the Toolpak. So we'll go over here to data. Yeah, awesome, Peyton. Thank you for being here. Data analysis. And we want to do the descriptive statistics, I believe. And let's go here on OK. Input range. We are going to input our variable here. We're going to make sure it knows labels are there. Output range. We could just copy the output range. Oh, it's having us select it. I think it is, unless it just broke something. C19 to H34. G19. Making me look around. G19 to H34. Do all my work for me. I like doing my own work. Well, it's going to override my stuff. And check both summary statistics and enter the correct confidence level and sample size. Confidence level, I'm going 90. Make sure you enter in your values. I'm doing different work. And I think we're good. I'm going to override my work. There we go. Overriding my work. Probably breaking my interval down there. So there's the n right there, the sample size. And there's the work, the mean. So we could rearrange this because I think this is where it was at. There's the mean plus we'll see if we can fix all this up. The confidence level is 90. The t is this, the standard error. So the standard error is that value right there. And that fixed the margin of error now. So the margin of error is actually, I don't know if it's fixed. It doesn't look fixed. Oh, wait. I did something wrong right here because the standard error is the standard deviation divided by the square root of n. So we need to take that. There we go. And if you notice, it sees that you should get the same answers. So you want to make sure you're getting the same answers when you do it by hand, and you should know how to solve this formula. If you're not getting the same answers, Excel's just doing it easier for you. This is a 90% confidence interval. This is the margin of error, and that's why Terry put this right here. It points to the margin of error. And then these formulas down here are using this. I kind of went sideways on that. Sorry, I was like, what is that's just interesting. Because I'll tell you, when I solve intervals, I'll show you how Brian does this. Let me show you in practice, because I think that does everything. We've done the Toolpak here. We've done the work. We've got everything solved. Let me show you how Brian actually makes intervals. Okay. Stat 201, how Brian makes intervals. Okay. Let me pull up my program. How do we actually make intervals in practice when we're doing real statistics? I mean, Excel's good. Excel's great. Excel is a great way to make intervals. But here's what I do. I might say something like, I want to figure out let's say that first thing I had a total of 9 out of 200. So here we are. I am 95% confident. You see 95%? I am 95% confident the true proportion of holiday days are contained in the interval 2.2 to 8.6%. And we should be able to go, is it confidence? Conf level. There we go. I am, see it's 90% now, so it's a smaller interval. I can change it to 98.5. Just makes the interval like that. Just so X is the number of successes. If you notice right here, when I go prop test, it literally just asks you for the number of successes, the number of trials. There's other things you can change. If we want to do the t-test right here, go to t-test, and maybe we're looking at the cars data, and we look at the miles per gallon. I am 95% confident the true miles per gallon of these cars is contained in the interval 17.9 to 22.26. Usually the hardest part is getting data, cleaning data, finding good data, trusting your data. Data is the tough part. The analysis part takes seconds. I am 95% confident the true average miles per gallon of the cars is contained in the interval 17.91 to 22.26. And you could just change right here like conf level and change it to a 90%. There you go. I am 90% confident the true mean mileage of these cars is contained in the interval 18.28 to 21.89. It's just that quick. That's how you do it like that. And you also do a t-test this quick. T-test we'll be talking about here soon. Or you do the prop test. They're related, the proportion test and the t-test. They're both tests, and they can both have confidence intervals that overlap with what they do. But I think for a lot of people, they realize like we're doing a lot of the same work right here, and then you realize a lot of times it's just getting tech to give you the answer, which you can use ChatGPT now. I bet you I could go here. Let me go to the MT cars data, and something tells me, let's go take this data over to ChatGPT. And here we are. Here is my data on MPG of cars. Make and interpret a 95% confidence interval. And so (32 observations). Find the standard deviation. Find the sample mean. I thought this said S also. Find the sample mean. Finding that. There it is. Y bar. I use Y bar. X bar is the same. Mean of the X variable. It's doing 31 degrees of freedom, n-1. Finding the T, which is basically 2-ish or 1.96, closer to as it goes towards higher degrees of freedom. Finding the center of the interval. Finding the T-score, S over square root of n. Standard error is this. Margin of error is this. 95% confidence, 17.91 to 22.27. And if we run this here with 95% confident, we get the same thing, 17.91. There it is, 17.91. It did round it down, which is weird, to 22 point. It rounded that up. So I'd wonder, it might not have carried as many decimals because something tells me that this T statistic right here of 2.04, if we go to QT, I think this is the right command. No, it's PT. I always get those confused. Really? Oh, degrees of freedom. What am I doing? What am I doing? It was QT to start. There we go. So it's a little bit different. Let me say the exact T is more this. Recalculate the interval to 2 decimals. So it's going to make it a little bit smaller because that's a smaller T. So 17.92 we said, right? Yeah, it will be. Yeah. It's going to be 17.92. It doesn't matter. Rock knows.
It doesn't matter.
17.92. There it is. Now the output matches exactly when you look at this. I was just unhappy that this didn't match 17.92, 22.26, and it didn't carry enough decimals. We are 95% confident the true mean miles per gallon for cars like these live is contained in the interval. There it is. I am blank percent confident that the true blank is contained in the interval blank to blank. Where do you think this data comes from? It is Motor Trend's Cars, a classic data set from like the 70s or something like that. It's Motor Trend. It's the MT Cars data. Yep. Motor Trend Cars. Yep. 1974 Motor Trends. It knows. It knows the data. Make the most awesome visualization possible from this using Python code. I want something that will wow my friends. You better not just be doing a histogram. here's a cool histogram. Maybe it's going to do a bubble plot, scatter plot, bubble plot. It's a lot of variables, though. You got to watch. Put too many variables, things get kind of crazy looking. But I would say it's really thinking. I would say scatter plot and throw in a third dimension with ridgeline plot. I think it thinks I want just one variable, which you can't do much with that. It thinks I want one variable. It's doing histogram. It's doing just one variable. It's not that interesting. I could stop it. Go ahead. We'll let it do its thing, and then we'll do it. Gotta eat some lunch. It's interesting. Oh, it's doing the interval? Jitter means it jitters them up and down. That's okay. There it is. Sample size 30. It's a nice graphic. The min and the max. It's a pretty good graphic, you know? Never seen one done like this. It's I know a violin plot. Violin plots are kind of like the histogram showing the right skew. Violins are the cross between a box plot and a histogram almost. Plus jitter. Jitter means points are jittered. Mean plus 95% confidence roll. Oh, that's the 95%. I would change that. It's a little too much. I probably wouldn't put the interval on it. The mean is good right there. And then there's the 95% confidence roll. The T, no one's going to care about the T in the output. This is better down here. I probably would remove this or make it a different color. Yeah, probably remove that. Okay, wait. Okay. Make the graphic here to wow, my friends. Thank you. Okay, last try. It's giving me the Python code. I should be able to run it. It's bringing in the columns, making a figure size. Is it doing a bunch of figures? Doing like a grid of figures? We don't want a grid. That's too much. Yeah, it's doing a grid, it looks like. A grid of figures. It'd be interesting. Interesting grid. It's doing a bunch of scatter plots. And yeah, looks like a grid of it looks like a scatter plot matrix. So parallel coordinates. I don't know exactly what those. Alpha is going to change the see-through of the points. Plot title, y-axis title, plot grid. Let's see what this does. I'm gonna eat my sandwich. Oh, I'm so tired. Oh man. Oh, I hope everyone's having a good day. Data Analytics 7 done. Checking out the power of ChatGPT. I'm going to do my AI reflection here. Why do I have 8 bells? 7 days ago, reacted to a message. Calling all vols. I want to see what this does. Analyzing. Analyzing. I'll take off the message here. It's a lot of analyzing. What happened to ChatGPT? I used to say make me graphics and it went like this. What happened? Why are you so slow? We should ask ChatGPT that. It was a long time analyzing. You say like, I got a paid version. Makes you wonder. Sometimes ChatGPT will be like, do you want the $200 plan? I'm like, no, thank you. It's going to be like a $2,000 plan. You want the $200 plan? It's all right. Is it movable? File not found. Thank you. Oh, there it is. Oh, it's just a PNG. I thought it was going to be movable. I don't think PNGs can move. Worst. It is a, it's a, whatchamacallit, trivariate display. It's pretty good. We could make it. It's cool when you can like shift it. You can do it inside of R. Wait. Give the R code. We're fine. We don't need to remember ChatGPT. With that, I'm going to go eat my sandwich. Bye for now, everyone. Bye.